This is the fourth video in support of what state space resources are within the Control101 toolbox. So state space methods are clearly powerful and popular tools, and therefore it's not surprising that we have a dedicated section within the Control101 toolbox. And this particular video is going to focus on the resources that support controllability and observability, along with basic feedback and estimator design. Now, as ever, you're reminded that the quickest way to access the file is through the shortcut interface, and you'll see circles around the particular files that we're going to look at in this video. So we're going to look at files on controllability and observability, basic state feedback design, observer design, and optimal state feedback. And as ever, it will be more effective to do a live demonstration rather than trying to describe these files in textual form. So first, let's look at the controllability and observability file. Now, as is common within this toolbox, you'll see the files start with detailed theoretical background, basically explaining what are the concepts of controllability and observability and giving some of the theory behind it. So you'll see quite a lot of mathematical detail and explanation here to get the user grounded before we actually move into MATLAB itself. So having got the grounding, again you'll see it then says, well, here's how you can do it in MATLAB to illustrate some of the core concepts that we've just been discussing. So more general controllability methods, so introduces the controllability matrix, and again you'll see the MATLAB code and illustrations below, making it clear how you can do this yourself and use MATLAB tools to make life nice and easy. A section here to emphasize that extensions to discrete systems are straightforward, and then again observability, some discussion what is observability, where's the MATLAB code to support this, more general observability methods, and so forth. So hopefully you'll see that's the same as normal. So once we've done observability and controllability, we can start moving to things like feedback. So the feedback file again has all the normal theoretical background. What is state feedback? Why do we think this might be useful? And basically, we start with pole placement because that's common in the literature to show that in principle with the state feedback you can move the poles. And so you'll see a little bit of code here to illustrate the concept, and then further demonstration that if you have canonical forms, pole placement is really simple and really clear. So here's the theory behind it, and here's some code illustrations with a few examples. But of course, systems aren't normally in canonical form, so we move on to how do we get the system into canonical form so that we can do our state feedback. So again, a bit of theory here showing how, and then the corresponding MATLAB code showing how you actually implement this and design your feedback design. A bit on Ackermann's formula, which explains how you go about this, and of course MATLAB built-in functionality so that once you understand the theory you can shortcut a lot of this with just a simple command. Okay, so having done state feedback design, people who understand state space will realize that observer design is really an analogous process, but again we have the theory at the top of the file explaining to the students what's going on, what's an observer, what's the analysis that goes behind this, what's the duality with feedback design, and therefore how we can exploit feedback design methods to do observer design. So the first part in section 2 is observer design using pole placement, so it builds on the previous file and therefore the code is somewhat more concise. We don't need to do every detail, so it shows you how can I use MATLAB to design an observer. And then you can start looking at the impact of the observer on closed loop behavior. And so clearly you can see with and without an observer you get different behavior because one is estimating the states and one is assuming the states are known. What happens if you introduce parameter uncertainty? So your state estimates may also be erroneous. And again, you can see how easy that is to illustrate. And then finally, a file on optimal state feedback. So pole placement as a rule is somewhat limited and not easy to do systematically. So this file introduces the concept of optimal state feedback, shows how you can systematically choose an appropriate state feedback gain. And here again, as ever, you have the code, and it steps through basically the sort of tools you've got for going about doing this design, an emphasis that it also works in discrete time, and a number of examples. So this short video has given a quick review of the feedback design resources to support the study of closed-loop state-space system behavior. So in closed loop, we basically need feedback and state estimation, and these of course rely on controllability and observability.